Consider the functions f, g, and h defined as follows. For t is a real number, f of t equals sine 2 times t plus 1, g of t equals sine 2 times t plus 3, h of t equals f of t plus g of t. Show that h of t equals imaginary of this expression. First, let's check what is the imaginary of e to the power of 2 times ti times e to the power of I plus e to the power of 3i. When you distribute this expression into the parentheses, you will see that e to the power of I times in parentheses 2 times t plus 1 plus e to the power of 2 times t plus 3 times I, right? And we're gonna now explain the Euler form of a complex number. It is if there is a e to the power of I theta, we can write in this in the polar form, which is cosine theta plus I times sine theta, right? Yeah. Now I'm gonna apply this. So imaginary of first cosine 2t plus 1 plus I times sine 2t plus 1 plus cosine 2t plus 3 plus I times cosine 2t, sorry, it's gonna be sine 2t plus 3, right? And from here you can write the imaginary of, as you see, the terms with I. So I will get the terms with I, sine 2t plus 1 plus sine 2t plus 3. Yeah. This is gonna give us h of t, which equals f of t plus g of t, right? As you see from here. At the second question, it asks for e to the power of I plus e to the power of 3i in the form r times e to the power of I theta. So how are we gonna do that? If we would like to write in e to the power of 2i times, uh, in parentheses, we need to write e to the power of minus I plus e to the power of I to make it similar to the previous question. Why we did that? Because in parentheses, you can see, or I can write in the polar form, all of them. It is cosine 2 plus, let's say, yeah, but we already gonna write it. Yeah, okay. E to the power of 2i times cosine minus 1, because there is minus 1 in front of I, plus I times sine minus 1, plus cosine 1, which is in front of here, 1, plus I times sine 1, right? As you see from here, uh, minus sin 1, this is, and sine 1 will be cancelled. And from here you can say e to the power of 2i times cosine 1 times, let's say 2 times cosine 1, because I know that cosine minus 1 is cosine 1. Yeah, we show it because it asks for this form. In this case, r equals 2 times cosine 1 and theta equals 2, right, which is in front of I. At the last question, hints or otherwise, write HOT in the form p times. Okay. We know that HOT equals the imaginary of, let's say, e to the power of 2i times e to the power of I times plus e to the power of 3i, right? And yeah, our goal is to write it p times sine 2t plus q. So how are we gonna do that? Let's write here again. It will be, we found in the previous question, what's that? E to the power of 2ti times, in parentheses, e to the power of 2i times 2 times cosine 1, right? Yeah, this is what we found in the previous question. And let's simplify it again. It is e to the power of I times 2t plus 2. It will come from here when you multiply it by itself, uh, times 2 times cosine 1, right? So imaginary of this complex number, let me write it in the polar form here, which is cosine 2t plus 2 plus I times sine 2t plus 2 times 2 cosine 1 In this case, the imaginary will be here, be in front of the I, the coefficient sine 2t plus 2 times cosine 1. So P is 2 times cosine 1 and Q is 2, right?